Let's solve a challenging differential equation problem. We need to prove that when y equals sine of sine x, the following differential equation is satisfied. Let's solve this step by step. First, we're given that y equals sine of sine x. Let's start by finding the first derivative using the chain rule. Now, for the second derivative, we need to differentiate this expression again. We'll use both the chain rule and the product rule here. When we differentiate cosine of sine x, we get negative sine of sine x times cosine x, and when we differentiate the second cosine x term, we get negative sine x. Notice that sine of sine x is actually y, so we can substitute that in. This gives us negative y cosine squared x minus cosine of sine x. Now let's look at the full expression we need to prove equals 0. We need to add dy dx times tan x plus y cosine squared x. Let's substitute what we found for the second derivative. And remember that dy dx is cosine of sine x, and tan x is sine x over cosine x. Now let's simplify. The negative y cosine squared x and positive y cosine squared x cancel out. And when we simplify, the middle terms cosine of sine x times sine x over cosine x just equals cosine of sine x, which cancels with the negative cosine of sine x term. And there we have it. We've proven that when y equals sine of sine x, the differential equation is satisfied because the left-hand side equals 0. This proof demonstrates the power of calculus and trigonometric identities working together. Thank you for watching.